We doing math today. Ain't got time for no games. We doing math today. All work and no play. We doing math today.
Hey guys, lesson 4.7, the multiplication counting principle and permutations. During this time, I know it's kind of sad, but normally I would be asking you guys, oh, you guys are looking forward to prom? What are you going to be wearing? Right? I got the tux, you got to get the shoes, and you got like your 3 different tuxes or 3 different shoes, and then the girls have like 2 dresses and like 5 shoes, right? You have all these different types of combinations or permutations. Learning target number 1, use the multiplication counting principle to determine the number of ways to complete a process involving several steps. Learning target number 2, use factorials to count the number of permutations of a group of individuals. And learning target number 3, compute the number of permutations of n individuals taken k at a time. All right, here we go. Learning target number 1, let's talk about number 1. Find the probability of an event often involves counting the number of possible outcomes of some chance process. Number 2, for a process involving multiple steps, we call that k. Suppose that there are n ways to do step 1, and n2 ways to do step 2, and nk ways to do step k. The total number of different ways to complete the process is n1 times n2 times nk. Basically, you just multiply them. Step number 3, the result is called the multiplication counting principle. Okay? All right. Example 1a. Too many choices. The Agricola restaurant offers a 3-course dinner menu. Customers who order from this menu can choose 1 appetizer, 1 main dish, and 1 dessert. I'm trying using different colors, but they change on me. Here are the options of each courses. So there's the appetizer first, then the main dish, and then the dessert. Draw a tree diagram. Okay, so we have this 3-course meal. I'm going to do a different tree diagram. It's pretty much the same idea. 3-course meal. 3-course meal. And you're first going to start off with the appetizer. And in the appetizer, you can get soup, you can get a green salad, or you can get a Caesar salad. I think I would choose a Caesar salad. Okay, from there, then you got to get a main dish. So you can either get pork, steak, chicken, or you can get salmon. And then the same thing for each of these, pork, steak, chicken, salmon. Same thing over here, 4 of these. Pork, steak, chicken, salmon. Okay, then you got to choose dessert. Dessert. You can have a cake or a tart. Cake or tart. I hope I choose a tart, like a fruit tart. C T C T C T C T C T C T C T C T C T C T C T. Okay. Now it is a visual, but it's kind of crazy, right? Because it's hard to display in this diagram here. This tree diagram looks kind of complicated. So what are some other ways of completing this problem? Well, basically what you can use is use blanks. Let's write that out. Use blank spaces. What do I mean by that? Well, here is the appetizer, here is the main dish, and here is the dessert. So how many appetizers are there? There are 3 choices, right? And it tells us above that to multiply. And for the main dish, how many main dishes are there? There are 1, 2, 3, 4. And then how many desserts? There are 2. So how many different meals can be ordered from this? 3 times 4 times 2 gives us 24 ways of ordering this meal. And if you think about it, if you went back up to our diagram, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. I missed something. Uh-oh, what happened? I can't count, but if you see my mistake, 8, it's right here, 9, 10, 11, there it is, 23, 24. I missed those. I don't know if you guys see it, but anyways, there's 24 of them, and if you just use the blanks, it probably would have been easier, but that's a visual using the tree diagram. Okay, you go ahead and try example 1B. Press play when you're ready to kind of try it together. Online passwords. How many 5-character passwords? Online passwords help protect confidential information. One website allows users to choose a password that consists of capital letters, lowercase letters, digits, and any 4 special symbols. The only other requirement is that the first character of the password must be a letter. How many different 5-character passwords can be created? Okay, so it's saying the first one must be a letter. So here's a blank. And how many letters are in? There are 2 sets of letters. There's capitals and lowers. So there's 26 letters and 20 capital letters, 26 lowercase letters, which means you can choose from 52 of these. Okay, then basically says that there can be any of these. So this would be capital, lower. We also see there's digits. Okay, there's 10 of them. 0, 1, 2. And the reason why I'm saying there's 10 of them, because if you count them up, including the number 0, so digits, there are 10. And then it can be, the last one can be one of those special symbols, special 4. So you just add all those together and you'll get 66. So it says the only other requirements is that, so there's a total of 5 characters, right? So on the screen I have 4 of these, and there is no other requirements. You can choose a lowercase, uppercase, whatever. And if you put that in your calculator, we're going to use our calculator a little bit more today. So 52 times 66 to the 4th power. That gives you that number. And that number is 986,686,272 possible 5-character passwords. Okay? Let's move on now to learning target number 2. All right, learning target number 2. The multiplication counting principle can also help us determine how many ways there are to arrange a group of people, animals, or things. We call the arrangements where the order matters. We call these permutations. A permutation is a distinct arrangement of some group of individuals. Next, we'll talk about something called a factorial. You may have heard it in your previous math class. What is a factorial? For any positive integer n, we define n, and it's an exclamation mark, which we read as n factorial, as n factorial is equal to n times n minus 1, n minus 2, and so on. So you can so for example, if you have something like 3 factorial, the formula will be, n is equal to 3, so you would just do 3 minus 1, 3 minus 2, and then you would basically get 3 times 2 times 1. That is, n factorial is a product of numbers starting with n and going down. Let's try this example here. Picture perfect. Suppose you have 5 photographs of different family members that you want to arrange in a line on top of your dresser. And how many ways can you do this? Okay, I'm going to call these 5 picture frames A, B, C, D, and E. Okay, let's think about this. You only have 5 photos and you have 5 locations, so let's use these blanks again. This is photo number 1, photo 2, 3, 4, and 5. Okay, so let's just say you pick letter. For photo number 1, you have 5 choices, A, B, C, D, or E. So you have 5. Okay, and then you cross it off. That means in photo number 2, you only have choices of B, C, D, and E. Well, let's just say you choose, let's use a different color here. Let's choose B here. That means here you had 4 choices. Now your next one, you would only have how many? 3 choices. And then you see what's happening is they're basically just counting down. You got 2, and then you have 1. So if you multiply these, 5 times 4 times 3 times 2 times 1, this is actually the same thing as 5 factorial. Remember the definition was if this is n equals 5, this is really 5 minus 1, 5 minus 2, 5 minus 3, and 5 minus 4. Okay? That's the formula. And if you multiply that, you would get basically 120. There are 120 ways to arrange those 5 photos on top of your dresser. Go ahead and try 2B, and then press play when you're ready. How many finishes? At a track meet, 8 different hurlers compete in a 400-meter hurdles. How many different ways are there for these runners to finish? Okay, so there's 8 different hurlers. So I have and essentially this is runner number 1, number 2, runner 3, 4, 5, 6, 7, and number 8. So each of these blanks here represents a runner. Okay, so how many people can finish in first place? Only one person, but you can choose from the 8. So again, if you like that idea, what I did, These are the 8 people. Okay. Well, one person has to finish first. You can say the person in 8th place does not matter. But the reason why I'm putting 8 here is because all 8 are eligible for first place. Okay. Who can get 2nd place? Well, there's 7 people left. That's why I'm choosing 7. Let's say this guy gets 2nd place. And then, does this make sense? You have 6 numbers left. 1, 2, 3, 4, 5, 6. And then it basically just goes down. And basically this is really 8 factorial. It's the same thing as 8 times 7 times 6 times 5, 4 times 2 times 1. Okay, so let's show you on the calculator. Okay, on the left side you're going to press math. Okay, then you're going to go to, this one's a little bit different. Number, complex, no. Probability, PRB. And then there you see the value. So I forgot to put the number 8 first. So let's try 8 first. 8, math, probability, factorial. And then you'll have 40,320. And let me prove to you that's the same thing as typing it all out. All right. So there are 40,320 possible finishes. Let's box that because that's our answer. Okay, let's move on to learning target number 3 now. All right, learning target number 3. So far, we have shown how to count the number of distinct arrangements of all the individuals in a group of people, animals, or things, right? The last problem had 8 runners, and then therefore, and how can they finish in the 8 places? Does that make sense? Sometimes we want to determine how many ways there are to select and arrange only some of the individuals in a group. Okay, let's go here. Denoting permutations. Permutations, the letter P is right here. Okay, so let's just write it out. Be super obvious. P means permutations. Permutations. Okay, and then if there are n individuals, so n individuals. Okay, so I'm also going to say that you can call this n equals the individuals, or I'm also going to say the word all. How many options are you choosing from? 8 runners. And then k individuals. So this would be the sum. Sum of the individuals, not all of them. Another way you can phrase this is blank out of, this is the total, pick blank or sum. So all, out of all of them, let's just say the runners, okay, let's just say the 2 top fastest winners go on to CIF, right? And so like, let's just say you have the 8 runners again. So let's just say you have something like 8, but you're only going to pick 2 of them. The notation you would have is 8P2. We'll talk about that formula in a second. Again, n was all. Okay, there are 2 ways to calculate permutations. Way number 1 is you can calculate the number of permutations of n individuals taken at k at a time using the multiplication principle. What did we use for that? Well, basically, my tip was to write out the number of what? What did we write out? Blank spaces. So that is one way. Way number 2 is to use this formula. So let me show you guys the formula. Total permutations, picking some of them is equal to the n factorial, so total factorial of total minus the sum of those factorial. Okay. Over here, I want to spend a little bit of time. What does 0 factorial mean? The question, and the answer is 1, and the question that might help you is, how many ways can you arrange 0 things? And the answer is 1 way. You can only do it in 1 way. Okay, let's try this example. If you're hungry, maybe pause, but 3A, what's for lunch? Your school cafeteria has purchased enough food for 12 different lunches over the few weeks. So I'm going to underline that one, 12 different lunches. Due to a holiday on Monday, there are only 4 school days this week. How many different ways are there for the cafeteria to select and arrange 4 of these lunches to serve? Okay, let's use blank spaces. Now, if you think about it, there's only 4 days. There's no school, so let's say this is a week. And this is Monday, Tuesday, Wednesday, Thursday, Friday. And they just said no school on Monday, right? Holiday. Okay, from the 12, on Tuesday, how many can you choose from? You can choose from the 12 different types of lunches. Maybe you have nachos, pizza, burritos, salad, french fry, all that stuff, right? Well, if you use one and you don't want to repeat it, then the next day you have 11, 10, and then 9. Now, here's the difference between the factorial, the multiplication principle, the basic one, from learning target number 1, is that you don't have 12 spaces. Let me say that again. Previously, we had 12 spaces for all 12 different lunches, but this one, I'm not choosing all, I'm only choosing some. Are you following? Okay, so now if you just put that in your calculator, 12 times 11 times 10 times 9, you will get 11,880 possible meal arrangements. Okay, that is using the blank spaces. Let's use the formula now. Using the formula, you have npk equals n factorial n minus k factorial. Okay, so there were 12 different meals, and you're going to pick only 4 days. So if n is equal to 4 and k is equal to, n is equal to 12, k is equal to 4, so n is 12 factorial, and then you have 12 minus 4 factorial. Alright, so what's going to happen is you will get 12 times 11 times 10 times 9 times 8 times 7, I ran out of space, 6, 5, 4, 3, 2, 1. Haha, sorry. And that's 12 factorial. And over here you have 12 minus 4, then the factorial, so that's 8 factorial. But watch what happens. 8 factorial is 8 times 7, 6, 5, 4, 3, 2, 1. Whoops. And basically what I'm doing here is these will cancel to equal 1. What does that mean? You're just left with 12 times 11 times 10 times 9, which we just did in the last problem, which was 11,880. So that's using the formula. So again, I can use blank spaces or the formula, and you'll get an answer. Now, let me show you guys how to do that using your calculator, permutations. Okay, you're going to do the same thing. So you're going to do math, probability, and then you see that under number 2, NPR. So I'm going to write 12, and then move over to the right, pick 4, enter, 11,880. Okay, so that's how you use them in the calculator. Remember, in my class, normally I would tell you first do it by hand and then check your answer with the calculator. Do not just put calculator commands or just a straight answer. Okay, go ahead and try 3B on your own. and then press play when you're ready. Example 3B, Math Scrabble. How many different 4-letter words? So a 4-letter word means there's only 4 spaces. Can be formed from the letters in the word equations. Okay, so it's kind of like a Scrabble, right? So if you like, I don't know, E-A-T, that's a 3-letter word. S, eats. That's one of my words. Does this make sense? And you have all of these possibilities. So 1, 2, 3, 4, 5, 6, 7, 8, 9 to choose from. In the case of words are just 4-letter arrangements. So if I put 9 here, let's just say I use the letter E, that means there's only 8 more letters left. And then in this spot, there's only, if I use A, then there's only 7 letters and then 6. Okay, and if you multiply all those together, you will get, so remember, if you need help writing stuff underneath, you don't have to, but just gives you an idea how to use these blank spaces strategy. There's a total of 3,024 words. All right, we're using the formula. Remember, it is NPK equals n factorial over n minus k, then that factorial. So our total is 9 letters, and from there we're picking how many? 4. So we'll essentially get 9 factorial over 9 minus 4 factorial, which gives us a 9 factorial over 5 factorial. And if you write that out, you will get 9, 8, 7, 6, 5, 4, 3, 2, 1. Right, we're counting down to 1. And then the 5 factorial is 5, 4, 3, 2, 1. And then we can just do some canceling here, right? So it's just 9 times 8 times 7 times 6, which is 3,024. Let's use our calculator, 9p4. Math, probability. Now some of you might have to type in the 9 first. It's number 2 in line. 9, right key, 4, enter, 3,024. All right, that finishes up page 3 and learning target number 3. Now go ahead and go on to example number 4, review it all. Do you scream for ice cream? And then go ahead and press play when you're ready. Example number 4, do you scream for ice cream? The local ice cream shop in Don Trell's town is called 21 Choices. Why? Because they offer 21 different flavors of ice cream. Don Trell likes all but 3 of the flavors that 21 Choice offers. So he doesn't like bubblegum, butter pecan, and pistachio. A 21 Choices basic sundae comes in 3 sizes: small, medium, and large. And includes 1 flavor of ice cream and one of the 12 toppings. Don Trell has enough for a small or medium basic sundae. How many different sundaes could Don Trell order that include only flavors that he likes? Okay, so let's think about the categories here. There are sizes. There are the small, medium, and large. There are, what's next? Flavors. And they told us there are 21 different flavors. We'll talk about Don Trell in a second. And then toppings, which there are 12. But remember now, he only has enough for a what? Small or medium. So that means no large, which means there's only 2 choices here. Flavors, there are 21, but he doesn't like 3 of them. So you take away 3 of those, you get 18. And he can choose all the toppings he wants. So if you put that in your calculator, you will get 2 times 18 times 12 is 432 possible sundaes. All right, let's try 4B. Dontrell could order a cone with 3 scoops of ice cream instead of a sundae. He prefers to have 3 different flavors for variety, and he considers the order of flavors on his cone to be important. How many 3-scoop cones with 3 different flavors that Dontrell likes are possible at 21 choices? Give your answer as a number. So you can use our method using spaces and blanks, and use the formula, NPK, the permutations notation. Okay, so here's the cone, and you have 3 different flavors, right? So let's use spaces and blanks. Okay, so basically for the first scoop, so flavor 1, how many can he choose from? But remember now, he doesn't like all 21 of them. He only likes what? 18. But if you use one of those, there's flavor number 2 is going to have how many now can he choose from? 17, because there's 1 less. He doesn't want duplicates. He says that he wants a variety. And of course, flavor number 3 is going to be what? 16. That's that last scoop. So 18 times 17 times 16 gives us 4,896 possible 3-scoop cones. If I just want to point out a word, because this was in the last lesson, the flavors that he's choosing for the variety aspect, this is called no replacement. Right? If you're talking about like cards, like, yeah, there's only 18 flavors he likes, but he's saying don't repeat the same scoop. So, I mean, you're not replacing that flavor into the pool that he can choose from. There's only 17. Okay, let's go ahead and try number 2. Let's use the formula. Okay, NP K n prime over n minus k factorial prime. Factorial. So how many are there can he choose from? Well, there is 18, and he's picking how many of these different flavors. He's only choosing 3. So n is 18. N is 18 minus 3. So again, you're going to have 18, 17, 16, 15. And you can just use those dots to go down. How's that? And that's essentially 18 factorial over 15 factorial. So dot, 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 dot. And then these all cancel, right? So you're just left with 18 times 17 times 16, which is the same number we had before, 4,896. Let's use the calculator, 18P3. Out of 18, you're going to pick 3 of those in some ways. That's what we kind of, let's see if that works. You could try second enter. That just repeats the formula. Go left and choose 18, 3, 4,896. Okay? All right, let's review what we've done so far. Learning target number 1, use the multiplication counting principle to determine the number of ways to complete a process involving several steps. Okay, that one, again, you're using all of the options, all of the blank spaces. If there were 8 runners, 9 batters, you're using all 9 batters. Learning target number 2, we use the idea of factorials to count the number of permutations. So factorial just basically means counting down from that number down to 1. And then target number 3, compute the number of permutations of n individuals taking k at a time. This is the NPK. This is saying, well, if you have 18 flavors, you're not going to have a big old sundae with 18 scoops of ice cream. Maybe Dontrell only wants 3 scoops, so that means you only have 3 blanks. And that's lesson 4.7. We'll see you guys.
We doing math today, ain't got time for no games. We doing math today, all work and no play. We doing math today.